Beringia land bridge stands as a pivotal threshold in human history, bridging two continents and forging the destiny of civilizations. Its icy expanse once connected Asia and North America, allowing ancient migrants to traverse the globe. In the distant past, during the Pleistocene epoch, the Earth's climate was vastly different from what we know today. The relentless grip of ice ages had transformed the planet, locking up vast amounts of water in glaciers and ice sheets, which in turn had lowered the global sea level by hundreds of feet. This drastic change had exposed a land bridge, a swath of terrain that would come to be known as Beringia, connecting present-day Russia and Alaska. The region was not a hospitable one, with temperatures often plummeting to -50°C and fierce winds howling across the barren landscape. As the ice ages advanced and retreated, the sea level rose and fell, alternately flooding and exposing the land bridge. During the last glacial maximum, which occurred around 20,000 years ago, the sea level was at its lowest point and Beringia was at its widest, stretching over 600 miles from north to south. This land bridge was not a narrow isthmus, but rather a broad expanse of tundra covered in grasses, mosses, and low-lying shrubs. The region was teeming with life, including mammoths, bison, and horses, which roamed the landscape in search of food and shelter. The earliest human migrants to cross into the Americas via Beringia were likely small groups of hunter-gatherers who had been living in the regions of present-day Siberia and eastern Russia. These individuals were adapted to the harsh Arctic environment, with technologies and clothing that allowed them to survive in one of the most inhospitable places on Earth. They were drawn to Beringia by the abundance of game, which provided a reliable source of food and sustenance. As they crossed the land bridge, they would have encountered a variety of landscapes, from coastal plains to mountainous terrain, each with its unique challenges and opportunities. One of the most significant factors that facilitated human migration across Beringia was the presence of the mammoth steppe, a vast ecosystem that stretched from Western Europe to Eastern Asia. This ecosystem was characterized by an abundance of grasses, shrubs, and other vegetation, which supported a diverse array of wildlife, including mammoths, bison, and horses. The mammoth steppe provided a corridor for human migration, allowing early travelers to move across the landscape with relative ease, following the same game trails and routes that had been used by their ancestors for generations. Irving's work helped to shed light on the complex interactions between the environment, climate, and human migration patterns, providing a nuanced understanding of the factors that shape the peopling of the Americas. His research, along with that of other scientists, has allowed us to reconstruct the landscape of Beringia in remarkable detail. From the types of plants and animals that inhabited the region to the routes taken by early human migrants. As we explore the work of William Irving and other scientists, we find that their research has shed light on the intricate dynamics of human migration across Beringia. One of the key factors that influenced this migration was the fluctuation of sea levels, which alternately exposed and flooded the land bridge. During periods of low sea levels, such as the last glacial maximum, the land bridge was at its widest, allowing for easier passage between Asia and North America. However, as the climate warmed and sea levels rose, the land bridge began to flood, creating a barrier that would have made human migration more difficult. The work of scientists like James Lumbers and William Fitzhugh has also provided valuable insights into the lives of the early migrants who crossed Beringia. Their research suggests that these individuals were highly adapted to the harsh Arctic environment, with technologies such as tailored clothing, sophisticated hunting tools, and portable shelters that allowed them to survive in one of the most inhospitable regions on Earth. For example, the discovery of ancient artifacts such as the Dorset culture harpoon points and the Thule culture whalebone houses has provided a glimpse into the daily lives of these early migrants. The presence of species such as mammoths, bison, and horses would have provided a reliable source of food and sustenance for early human migrants, allowing them to thrive in this harsh environment. The work of paleoecologists like Paul Collinvaux has shown that the Beringian ecosystem was characterized by a unique combination of tundra and grassland vegetation, which supported a wide range of herbivores and carnivores. The fossil record also provides valuable insights into the lives of these early migrants. For example, the discovery of human remains at sites such as Ushki Lake and Berilac has provided evidence of human presence in the region dating back to around 12,000 years ago. The analysis of these remains has revealed a fascinating story of human adaptation and resilience, with evidence of dietary stress, disease, and injury that would have been common among early migrants. The work of geneticists like Theodore Scher has shown that the majority of modern Native American populations are descended from a small group of founders who crossed Beringia around 15,000 to 20,000 years ago. This finding has significant implications for our understanding of human migration and population dynamics, highlighting the complex and nuanced history of human movement across the Americas. The archaeological record also provides evidence of early human presence in the Americas, with sites such as Monte Verde in Chile and Topper in South Carolina providing evidence of human occupation dating back to around 18,000 years ago. The analysis of these sites has revealed a fascinating story of human adaptation and innovation, with evidence of early technologies such as stone tools, fire pits, and shelter construction. The work of scientists like David Meltzer has shown that the peopling of the Americas was a gradual process that occurred over thousands of years, with multiple waves of migration and colonization that would have been influenced by factors such as climate change, sea level fluctuations, and cultural exchange. Their research suggests that these individuals were not just passive migrants, but rather active participants in shaping their environment and adapting to the challenges of the Arctic landscape. For example, the discovery of ancient artifacts such as stone tools, bone needles, and ceramic pottery at sites like the Mesa site in Alaska and the Kamchatka Peninsula in Russia has revealed a complex picture of technological innovation and cultural exchange. One of the key figures in the study of Beringian archaeology is Nikolai Dykov, a Russian archaeologist who spent decades excavating sites along the eastern coast of Siberia. Dykov's work at sites like the Yulin site on the Chukchi Peninsula has provided a wealth of information about the lives of the early migrants, including their diet, clothing, and shelter. For example, the discovery of ancient whale bones and harpoon points at the Yulin site suggests that these early migrants were skilled whalers, able to hunt and process large marine mammals in the treacherous waters of the Bering Sea. The study of Beringian archaeology has also been shaped by the work of anthropologists like Anne Feenup Riordan, who has spent years studying the cultural traditions and oral histories of the indigenous peoples of Alaska and Siberia. Feenup Riordan's research has highlighted the importance of storytelling and cultural exchange in shaping the identities and worldviews of these communities, and has provided a unique perspective on the lives of the early migrants who crossed the land bridge. For example, the stories of the Yupik people of southwestern Alaska describe a complex landscape of spirits, ancestors, and supernatural beings that inhabited the Beringian environment, and provide a fascinating glimpse into the spiritual and cultural practices of these early migrants. Their research suggests that the Beringian environment was characterized by a complex interplay of glacial and interglacial periods, with significant fluctuations in sea levels, temperature, and vegetation over the course of the last 20,000 years. For example, the discovery of ancient beach ridges and sediment cores at sites like the Seward Peninsula in Alaska has revealed a detailed picture of sea level changes and coastal evolution in the region, and has provided a critical context for understanding the lives of the early migrants who crossed the land bridge. The study of Beringian geology has also been shaped by the work of scientists like Scott Elias, who has spent years studying the fossil record of the region. Elias's research has highlighted the importance of Ice Age fossils in reconstructing the environmental history of Beringia, and has provided a unique perspective on the lives of the plants and animals that inhabited the region during this period. For example, the discovery of ancient fossils like the woolly mammoth and the giant short-faced bear at sites like the Fairbanks area of Alaska has revealed a fascinating picture of Ice Age ecosystems and extinction events in the region, and has provided a critical context for understanding the lives of the early migrants who crossed the land bridge. As the study of Beringian geology continued to uncover new insights into the region's environmental history, researchers like Scott Elias turned their attention to the impact of climate change on the land bridge and its inhabitants. The discovery of ancient pollen records and sediment cores at sites like the Norvik River in Alaska revealed a detailed picture of vegetation changes over the past 20,000 years, highlighting the significant role that temperature fluctuations played in shaping the Beringian ecosystem. For example, the presence of tree pollen in sediment cores from the early Holocene period suggested that the region experienced a brief warming trend around 10,000 years ago, allowing forests to expand into areas that are now tundra. This warming trend had a profound impact on the human populations that inhabited the land bridge, as evidenced by the archaeological record. Sites like the Mesa site in Alaska and the Kamchatka Peninsula in Russia revealed a shift towards more complex societies and economies during this period, with the development of new technologies and trade networks. The discovery of ancient artifacts, like ceramic pottery and stone tools at these sites, suggested that the inhabitants of Beringia were able to adapt to the changing environmental conditions and thrive in the region. One of the key researchers to study the impact of climate change on human populations in Beringia was archaeologist William Fitzhugh, who spent years excavating sites along the eastern coast of Siberia. As the climate continued to change, the land bridge between Asia and North America eventually became inundated with water, cutting off the migration route that had connected the two continents for thousands of years. This event, which occurred around 11,000 years ago, marked the end of the Beringian era and had a profound impact on the human populations that had inhabited the region. The descendants of these early migrants would go on to populate the Americas, developing complex societies and cultures that would eventually give rise to the modern nations we know today. The legacy of Beringia can be seen in the modern-day cultures of the indigenous peoples of Alaska and Siberia, who continue to maintain strong ties to their ancestral lands and traditions. Researchers like Anne Riordan have worked closely with these communities to document their oral histories and cultural practices, providing a unique perspective on the lives of the early migrants who crossed the land bridge. For example, the stories of the Yup'ik people of southwestern Alaska describe a complex landscape of spirits, ancestors, and supernatural beings that inhabited the Beringian environment, highlighting the deep spiritual connection that these communities have with the land. The study of Beringia has also had significant implications for our understanding of human migration and population dynamics. Researchers like David Meltzer have used genetic data and archaeological evidence to reconstruct the migrations of human populations across the Americas, revealing a complex picture of multiple waves of migration and colonization. For example, the discovery of ancient DNA in sediment cores from sites like the Bluefish Caves in Canada has provided new insights into the origins of the first Americans, highlighting the importance of Beringia as a gateway to the New World. As the field of Beringian research continues to evolve, new technologies and methods are being developed to study the region's environmental history and human populations. For example, researchers like Peter Schweitzer are using advanced geophysical techniques to map the subsurface geology of the Bering Sea, revealing new insights into the region's tectonic history and the formation of the land bridge. Meanwhile, archaeologists like William Fitzhugh are using cutting-edge dating methods to refine our understanding of the chronology of human occupation in Beringia, providing a more detailed picture of the lives of the early migrants who crossed the land bridge. The legacy of Beringia can be seen in the modern-day landscapes of Alaska and Siberia, where the remnants of ancient cultures and ecosystems continue to shape the lives of the people who inhabit these regions. The legacy of Beringia can be seen in the modern-day cultures of the indigenous peoples of Alaska and Siberia, and its impact on the course of human history is a profound reminder of the interconnectedness of our world. Thank you for joining me throughout this historical journey. That's all for today's History with Herodotus. Remember to like, share, and subscribe, and until next time, remember that, to understand the present, we must first understand the past.